I'm Anil Kumar, and now let us explore horizontal and vertical asymptotes with the help of graph of a function. Question is, determine the equation of the asymptotes and explain how the graph of the function approaches them. So that is the solid line which represents the function. Let me call this function as f of x. And these dotted lines are our asymptotes. The horizontal line is the horizontal asymptote. We can write its equation as y equals to 1. The vertical line is the vertical asymptote, which is x equals to 4, right? So at every point the x value is 4. Function is never 4, you can see. 4 is not in the domain of the function. However, function approaches 4, right? So as you approach 4, the function approaches infinity, right? So what you notice here is that the horizontal asymptote is the one which describes the end behavior, right? So when we talk about horizontal asymptote, we are trying to see what happens to the function as x approaches positive infinity or when x approaches negative infinity. What happens to the function? In this case, the function approaches the value 1, and therefore we say there is a horizontal asymptote, and the equation of horizontal asymptote is y equals to 1, correct? So that is how we'll be treating horizontal asymptotes. Now you'll also notice that on the left side, function approaches horizontal asymptotes from below, right? So this is from below, and here it is approaching from above. That is to say that the value of the function is slightly less than the horizontal asymptote as we approach negative infinity, but the value of the function is slightly more than the horizontal asymptote 1 as we approach positive infinity, right? So that is called the end behavior. So let me write down here end behavior. So end behavior is another term which we have to be very familiar with. End behavior is how does the function approach this asymptote, right? So what we notice here is that the limit of the function as x approaches negative infinity is actually equals to 1, but less than 1. So let me write this minus here. So it approaches from below, right? So it approaches from, we can say, from below horizontal asymptote, right? Now, limit of the function f of x as x approaches positive infinity is also 1, but it is approaching from above, so we can write this plus. So it is slightly more than 1, so it approaches from above the horizontal asymptote, right? So that is another way of describing the graph. So once you know this description, you can actually sketch a very accurate graph. So this is very important to understand. Now, let us analyze vertical asymptote. So vertical asymptote is the one where when we are approaching that value, function approaches infinitely large value. So what is happening here is that the limit of the function f of x as x approaches 4 is actually becoming positive infinity. Do you see? It becomes positive infinity. It is very, very large. Similarly, limit of the function as x approaches 4, this 4 is from both the sides, right? 4 minus means from the left side, and if I write 4 plus, then also it is approaching plus infinity. So limit of the function as we approach 4, from either side, the function is approaching plus infinity. Do you see that? So that makes it a vertical asymptote. Vertical asymptote is a vertical line which the function is trying to approach as you approach closer and closer to the x value of that, right? So that is what it is. Now, so we have to describe what happens to the function's graph as we approach the vertical asymptote from left and right. So that is to say, infinite limits. So we analyze, so this is called analysis of infinite limits. So sometimes we may use this term that find vertical asymptote and analyze infinite limits. That really means when you're approaching the vertical asymptote from left side and from right side, whether the function approaches positive infinity or negative infinity. It could approach negative infinity also. In this particular case, from both sides, we are approaching positive infinity, right? So that is how it is. Now you'll find this example is very typical. Your graph actually crosses the horizontal asymptote, but your graph will never cross vertical asymptote, right? And you also notice that the graph of the function may approach horizontal asymptote from above or below. So it is very important to find it out. I hope that helps. Thank you.